Welcome back my dear friends and dear students. A very good morning, good afternoon, good evening to all of you wherever you are at whatever time. And this is the DADM 2, which is Data Analysis and Decision Making 2 course under NPTEL book series. And as you know, this course is for 12 weeks, which is spread over 60 lectures, and the total duration in hours if you calculate is 30 hours. And each week we have 5 lectures. So, and which each lecture being for half an hour, and after each week we have assignments to be solved by the students, and as you know, after this course there will be a end sum examination. And my name is Raghunandan Sengupta from the IME department, IIT Kanpur in India. So, this if you see the slide, this is the DADM lecture number 30, which is the 6th week end of the 6th week classes. So, we will try to wrap up the ELECTRE process. In the ELECTRE process, initially we had discussed about general ELECTRE, then we were basically talking about epsilon ELECTRE, and in epsilon ELECTRE, if you remember, I have been discussing that how you can make your decision choice in such a way that you have the discordant set, concordant set and the indifferent set, and depending on the liking, disliking, I will basically divide my whole choice. My means the decision maker choice can be divided into 3 mutually exclusive and exhaustive sets, where concordance means when I take a decision A k with respect to A L and J being the criteria, if I am willing to take that, I get some positive points, hence I will basically put that value of J into the concordance set or C, and ultimately it comes into the those values that will be utilized to find out the matrix capital C. And if I am able to take a decision A k with respect to A L, but in the case the criteria J does not give me that benefit. So, those index value or indices values which does not support A k will be utilized to calculate the D matrix, which is the discordant matrix. And in the epsilon method, we added a extra set of decision making tool or a rule for decision making, where that indifferent set would also be covered, where we are whatever decision we take with respect to J, if J means the criteria, if A k and A L does not give me any benefit by taking A k, I will put that J into the set which is I in indifference indices values, which will be utilized finally to calculate the indifference matrix. And if you remember, I did also mention in the last class, which was in the 29th class, that the indifference matrix or indifference set can be asymmetric values, in the sense that we can utilize the asymmetric penalty loss functions based on the civil engineering problem, the marketing problem and the electrical engineering problem accordingly, where we can bring some concept of practicality into the decision process. So, continuing our discussion, if you remember, we were doing the values, calculating the values of C11, D11 and I11, where C, D, I are basically the values in the concordant set, discordant set and the indifferent set. Similarly, we will calculate C12, C1, after that we will consider C12, C D12 and I12, then go into C13, D13 and I13. So, we will go column wise or row wise. So, here we are trying to calculate C21 and D21 and I21, corresponding to the fact that these are, as I mentioned, I am again repeating, concordance concept, discordant concept, indifferent concept. So, we take again the values of epsilon means the difference which you have, as 0. I will highlight it as 0.01 for all the cases. I am not changing it, even though I did mention that you can consider depending on the J value, the epsilon value can change, but I am not considering that. So, for J is equal to 1, we will have the values compared the y21 with respect to y11, and we will see that I1, which is J is equal to 1, falls in the concordant set. Similarly, for J is equal to 2 falls in the discordant set, and J is equal to 3 falls in the indifferent set. So, we have for C21, D21, I21 the values as marked in the yellow highlight pointer. Then when we go into C22, D22, I22, obviously here the comparison would be comparing amongst themselves. So, obviously all of them would fall into the set of indifferent, because I am now indifferent, whether I like it or not like it does not matter now, because I am indifferent between trying to compare one with itself, like comparing the 1 with 1 or 2 with 2 or 3 with 3, but here we are doing the 2 comma 2 cell values. So, obviously in that case the null set would be C, null set would be D, and the I set would have all the elements which is I j, I am j is equal to 1, j is equal to 2 and j is equal to 3. Now, obviously, I will go to the next level would be C22, C23, D23, I23, then we will go to C31, D31 and I31. So, C23, D23 and I23 would be the so called values in 2 comma 3 cell in the whole overall matrix, where each cell, if you consider the 3 by 3 matrix, over the cell would have elements corresponding to C, D and I. So, the 1 comma 1 would be C11, D11, I11, then 2 comma 2 would be C22, D22, I22, and the 3 comma 3 cell in that matrix would be C33, D33 and I33. So, when you are considering 2, 3, it will be 2 comma 3 cell position. So, corresponding to j is equal to 1, 2, 3, which are the criteria, if you again compare, again considering the fact that we are taking epsilon as 0.01, which is just an assumption, simplistic assumption, we have that the value again, okay, now here I will try to use the different colors, like in the indifferent set it will be yellow, in the concordant set it will be green, and in the discordant set it will be red. So, as it is indifferent set, 1 falls in indifferent set, 3 falls in indifferent set. So, 3 is 1 and 3. Now, the correspondingly in discordant set 2 falls there. So, 2 becomes red in color, and the green one is a null set because C23 is null, hence it falls in the null element is there in C23. When I go to 3 comma 1 cells, that hence we have to consider the concordance, discordance and the indifferent sets as C31, D31, I31. So, if we consider again j is equal to 1, 2, 3. So, j 3 are the criteria, it can be more than that also. Corresponding to that, we have 1, 2, 3 all falling in the indifferent set. So, obviously, they would be yellow. So, the indifference set has all the elements 1, 2, 3, and the corresponding D set is null, corresponding C set is null. So, we are trying to now differentiate, if you remember the real line, trying to divide into 3 zones. One in between zone which will depend on the epsilon value would be the yellow one, where in indifferent. On to the right, when I am looking from my side, would be the green one, which is concordance, positive one, and on to the left of that indifferent zone would be the red one, which is the discordant set. Now, I go to the cell number 3 comma 2 in that overall matrix. So, again, I will consider C32, D32 and I32, and corresponding to j is equal to 1, 2, 3 when I calculate. I am not going to the detailed calculation, you can basically check, and we are considering epsilon value as 0.01 for all the 3 cases, j is equal to 1, j is equal to 2, j is equal to 3, all that criteria, we are not changing them. So, based on that, when we technically would have j is equal to 1 is indifferent, j is equal to 3 is equal to indifferent, and if I come to the concordance values, it is 2 is equal to concordance set. So, correspondingly C32 is element, only one element which is 2, that is j is equal to 2. If I consider red, it is which is the discordant is a null set, and if I say consider yellow, which is the indifferent set, would be 1 and 3, j is equal to 1, j is equal to 3. Now, I come to the last cell which is 3 comma 3, then you will have basically the concordance, discordance and the indifferent concepts would be C33, D33 and I33, the indices. Similarly, for j is equal to 1, 2, 3, considering epsilon as 0.01, using the same calculation which I have shown, we will basically have all of them falling into the set C. So, they would be 1, 2, 3 falling into, oh, it is my mistake. I think I have done it something wrong. Let me change it. Sorry, just change it here. So, they would be technically 1. It is my typo error. Sorry for that. Extremely sorry. So, once I have this, let me save it. So, I will again highlight the appropriate colors for the cell 3 comma 3. So, I will have corresponding to I. So, this is 1 is equal to 1 3, 2 is equal to 1 3, I is equal to 1 3 3 3, 3 is equal to in I 3 3, 2 is equal to I 3 3, 1 is equal to I 3 3. So, the indifferent cell has all the elements 1 2 3, and the corresponding cells or the element in C 3 3 is null, corresponding cell in D 3 3 is null. So, you have formulated the rule. So, now if you see the relative structure of the construct which are formed. So, 1 comma 1, 2 comma 2 and 3 comma 3, all the values I will use the yellow, I will use the, say for example, the violet just marker. So, the indifference set in the principal diagonal are all the elements. So, liking, disliking, that is liking means concordance and disliking means D, discordance sets are null. So, in the principal diagonal, everything when you compare, you are indifferent in the decision. And if you take the concepts of the diagonal element, then you will basically have the indifferent and the this concordant set and the in this discordant set values, based on which you will proceed. Remember that this actual value of C, this capital C which I have written is just nothing to do with concordance, just a symbolic representation of that matrix C. So, this should technically be asymmetric in nature. Now, consider the weights are given. So, what I do is that, or what we considered is that we consider different weights for the concordant set, different weights for the indifferent set and different weights for the discordant set. So, weights are considered in a way such that I will assign 1/3, 1/3, 1/3 for the case for concordance. That means, the top rows values would be 1/3 for the 1 cross 2, and corresponding to the diagonal element along the principal diagonal, the opposite mirror image which is 2 cross 1 will be 1/3. And if you consider here 1/3 and the opposite elements dash, it means the liking disliking concept has been formulated accordingly. Similarly, for the indifference one, it is a mirror, not a mirror image, the principal diagonal is 1. When I compare 1 2 2 1, I am indifferent. When I compare 2 3 and 3 2, it is indifferent. But when I compare 1 3 and 3 1, then obviously this value of 1 and dash basically gives the indifference concept much more starkly. Similarly, I have the discordance weights, and based on that, what is important to note is that if you find out the sum of all the corresponding cells for this weighted or weight matrix for CDI, it would be 1, and that can be that will give you an idea that based on the weights you are doing you have done the normalization in the right way. So, if you add up, say for example, first element dash, second element 1, third element dash, so it is 1. If you add up 1/3, 1/3, 1/3, it is 1. If you have dash dash 1, it is 1. So, if you add up 1/3, 1/3, 1/3, it is 1. Then if you add dash 1 dash is 1. Then if you add dash 2/3, 1/3 is 1. So, lastly going to the last row, dash dash dash, okay, you have to check this, there must be some, I will double check that. So, it should be definitely be 1 here also, my mistake. So, I will verify that. 2/3, 1/3, yeah. So, this should be, so if I add up 1, so now it should be dash 1 dash is 1, then 1/3, 2/3 dash is 1 and dash 1 dash is 1. So, all these values comes out to 1. So, in this principal diagonal value wise, the symmetricity is maintained in the indifference part, not in the case for the discordant set and the concordant set values. Now, if you follow the rule, again we will just follow the same concept what we have done for the discordant factor, like we give a range and try to find out the maximum value based on all the combinations. So, when you are trying to compare, we will compare one cell value with respect to all the combinations which will be there along the row or the column, depending on which way you have normalization you have taken place. So, you will basically find out the small c value, small I value, small d value when you are comparing the kth and the lth decisions based on the criteria j. So, you will basically compare them for all the criteria and basically take the max value or the ratios accordingly. So, if I do that, so I will just go, if you remember the values, the cells, let me write it down so it is easy for you. So, this will be good point. Let me take these cells values. So, if I, so sorry I am not skipping, but I am trying to bring that slide in the picture. So, it will be easier for us to compare. Please bear with me, because I thought initially then, because it was, so I will remove this and this y values will be utilized accordingly. So, I will use this time and again. So, I am copying it for our own benefit. So, we have these values of y. So, it will be now much easier for us to denote. Yes. So, for all the students and the readers, I will basically request them to have a look at this matrix, which was y. Y was basically the normalized using the utility sense and normalizing along the row or the column, the x matrix multiplied the weights, we had that y values, and based on that we are trying to proceed. We have already found out the concordance and discordance concept. So, given the concordance and discordance, I find out the cell values. So, C11, then C22 and C33, the principal diagonal will be dash dash dash, because concordance and discordance concept does not come here. So, if I use these values, so C12 becomes 1, C13 becomes 0, just pause and see. So, you will basically take the maximum of these values accordingly. So, once you have that, I will just proceed accordingly. So, then once C21 will be 0.5567, C23 would be 0. So, if you check here, 1, 2 and 1, 3 are the placements of the cells which you are talking about, 1, 2 to 1, 3. Similarly, when you come to 2, 1, 2, 2 would obviously will be the dash 1, 2, 3. So, corresponding values of C2, 1 would be 0.5567, and use the same formula which you have just discussed, that for the C value, I value and the D value, the small c I d which I have just mentioned, and utilizing the y matrix normalized values. So, C23 comes out to be 0. Similarly, 3, 1 which is C31 would be 0, C32 would be 1. Now, you have found out the C values. Similarly, you have to find out the small I values. Similarly, to find out the small d values, and the calculations would be given here. I will just go through the final results. So, once you have that, the C matrix comes out to be here. This is basically the concordance so called matrix which you have. The principal diagonal which I mentioned is dash, and of the diagonal elements have been given. So, only part is to require is, if you compare 0.5567 with 1, it means that if I take 1 with respect to 2, I get much more benefit than when I take 2 with respect to 1. That means, for the conglomeration of the collective positive points which I get for choosing 1 with respect to 2 for all the criteria taken together, I get a much higher benefit. Similarly, when I come to I11, I22 and I33, which is the principal diagonal in the capital I matrix, this is the indifference matrix, it will be dash and the off the diagonal elements are calculated here. So, I12 is 0.11, I13 is 1. Similarly, when I go to I21 and I23, the corresponding values are 0.11 and 0.2863. I am going a little bit fast because if you check the formula, they are just a repetition, just put them and solve it accordingly. Similarly, I31 and I32 values are 1 and 0.2863. So, based on this, when I find out the indifferent matrix, the value comes out to be like this. So, this would be a symmetric matrix, because in the indifferent matrix here the concept of symmetricity would hold true, not for concordance and discordance. Concordance and liking in and disliking concepts are little bit different. So, this is I will use the highlighter, this is symmetric, this is symmetric and this is symmetric. So, that was not the case when we consider the C matrix, and we will also see may not hold true for the D matrix. Similarly, when I come to the D matrix, which is the discordance actual matrix which you have. So, similarly D11, D22 and D33, the principal diagonal will be dash values, because you are not comparing them, and the off the diagonal values are given as D12 is 0.5567, D13 is 0. When I go into D21 and D23, the values are 1 respectively in both the cases. And when I go to D31 and D32, both the values are 0. So, utilizing this, when I have the D matrix, so you check. So, the principal diagonal values are not symmetric, and this is very important. This is symmetric, that is coincidence, but this is also not symmetric. Oh, I should use a different color. So, this is also not symmetric, and this I will try to be seen. I am using a different color in order to note down. So, this is also, this is symmetric, but other elements are not symmetric. Now, I need to find out the C star, I star and D star values. So, these are the average values which I find out, the formulas which I use depending on m into 1 by m into m minus 1, the values which you have, the values which you calculate for the concordance, discordance, dominance matrix and the indifference matrix which you want to find out. C star comes out to be 0.1667, I star 0.7778, and again this should be D star. So, this value comes out, the D star also comes out to be 0.1667. Similarly, based on this, I need to find out the capital F matrix, capital G matrix, and then multiply the corresponding elements for F and G, then find it out. So, the concordance concept, the discordant concept and the indifference concept for the liking and disliking are, if you remember in the general ELECTRE process, were basically subsumed under the matrix F, which is a set when I take the positive decision. G was the set when I take the negative decision, and then I try to compare them and find out that if I multiply those values, whether they are positive or 0. So, once I have the F set for C, I and D, so the values are coming out to be these. Remember, for the principal diagonal, they may be symmetric, definitely symmetric for the I indifference concept, but not for the D and C. So, if you check, so I will use the red, this color scheme has nothing to do. So, this is symmetric, and here in D this is symmetric. If I consider this one, this is asymmetric in the D set or this D matrix, this is asymmetric. But if I consider the values for I symmetric, symmetric symmetric. So, I would continue remaining the symmetric one and not for the D or C. It may be just a coincidence if C and D are symmetric, but it would not be. So, when I go and try to find out the G capital matrix when I am taking the other decision. So, what is the disbenefit? So, correspondingly again the values of C, I and D, concordance average values, discordance average values, indifference average values, they come out to be 0.4261, 0.4654 and 0.4261 again. So, based on that, once I formulate the G matrix for C, I and D, again you will see these values which I have. I will use the color for blue. So, this is symmetric, which is fine. This is symmetric. For I matrix, everything is symmetric, remember. And this is also symmetric here, but for C and D, as there is symmetricity and asymmetricity, these are the case. And once you have them, you will basically want to find out the combined effect. Like if I have taken K, when I try to find out the benefit, I break down the benefit into C set, I set, D set and find out the total benefit. And then try to find out the so called disbenefit. Again I basically divide into C, D and I, combine them, and basically at the end of the day I have an F matrix for C D I, a G matrix for C D I. I can multiply the corresponding cells of C with C, C with D, C with I. The next would be, in order to find out the ranking, then I compare I with C, I with I and I with D, and finally, I will compare the concept of D, D with C, D with I and D with D. So, once I have that, so I will need to find out the E matrix. Only remember the subscripts. I have not gone into the detailed calculation. We need to find out ECC, that means concordance, ECI concordance and indifferent, ECD concordance and this concept of discordance. So, I will multiply the corresponding values from for the C set with the C set corresponding to F and G, then C set with I set for F and G and C set for D set with F and G. F and G will remain the same, only the subscripts are changing. When I go to the indifferent set, again I will have basically IC, II and ID, that is indifferent concordance, indifferent discordance. The values multiplied F and G, but the subscripts are IG, IC, II and ID. And finally, when I find out the discordance so called overall matrix, it will be DC, DI, DD, which is discordance, concordance, discordance, indifferent, discordance. The values multiplied would be from the F and G matrix, but the corresponding subscripts would be DC, DI and DD. So, with this I will end the 30th lecture, which has to do with ELECTRE process, both the ELECTRE and normal process and the epsilon ELECTRE, and we will consider the other topics of TOPSIS and other matters in the subsequent class starting the next week. Have a nice day and thank you very much for your attention.